Your brain is shrinking right now, about 0.5% per year after 40. That is not a disease, that is the default. But here is what nobody tells you. The rate is not fixed. People who keep learning new things lose brain volume significantly slower than people who stop. And people who stop learning entirely lose it faster than average. Your brain does not care about your age. It cares about whether you are using it. The mechanism behind this is called neuroplasticity, and it is the single most important concept in brain science. Neuroplasticity means your brain physically changes shape based on what you do with it. When you learn something new, neurons form new connections. When you practice that skill, those connections strengthen. When you stop, the connections weaken and eventually get pruned away. Your brain is not a hard drive that stores everything permanently. It is a living network that constantly rewires itself based on demand. Use a pathway and it gets reinforced. Ignore it and it gets dismantled. Your brain runs on a strict use it or lose it economy. The most famous demonstration of this is the London taxi driver study. Researchers scanned the brains of taxi drivers who spent years memorizing the labyrinth of London streets. Their posterior hippocampus, the part of the brain responsible for spatial memory, was physically larger than the same region in bus drivers who followed fixed routes. The taxi drivers grew more brain in the area they used most. The bus drivers, doing the same job but without the learning component, did not. This principle does not stop working because you turned 50 or 60 or 70. Adult neurogenesis, the birth of new neurons, continues in the hippocampus throughout life. It slows with age, but it does not stop. And the rate at which it happens is directly influenced by what you do. Physical exercise increases it. Learning increases it. Social interaction increases it. Chronic stress decreases it. Isolation decreases it. Boredom decreases it. Here is what happens when you stop learning. First, your brain loses stimulation. The prefrontal cortex, which handles planning, decision-making, and complex thought, requires constant challenge to maintain its synaptic density. When the challenges stop, when your days become routine and predictable, the synapses in this area thin out. Decision-making gets slower. Mental flexibility decreases. You become more rigid in your thinking, not because of age, but because of disuse. Second, your brain's chemical environment changes. Learning triggers the release of BDNF, brain-derived neurotrophic factor. BDNF is essentially fertilizer for neurons. It protects existing cells, promotes the growth of new ones, and strengthens the connections between them. When you stop learning, BDNF levels drop. Without it, your neurons become more vulnerable to damage and your synapses weaken. The brain shifts from a growth state to a maintenance state, and eventually from maintenance to decline. Third, the default mode network takes over. This is the brain network that activates when you are not focused on anything specific. It is the mind-wandering, ruminating, what-if network. In moderate doses, it is useful for creativity and self-reflection. But when it dominates because nothing is challenging your focused attention networks, it tends to loop into anxiety, regret, and repetitive negative thinking. People who stop engaging in new learning often report a vague sense of mental fogginess or purposelessness. That is not depression in every case. It is an unstimulated brain defaulting to its idle state. Fourth, cognitive reserve depletes without being replenished. Cognitive reserve is the brain's buffer against damage. It is built through education, complex work, learning, and mental engagement throughout life. People with high cognitive reserve can sustain significant brain pathology, including the plaques and tangles of Alzheimer's disease, without showing symptoms. Their brain has enough redundant wiring to route around the damage. But cognitive reserve is not a savings account you fill once and draw on forever. It requires ongoing deposits. When you stop making deposits, the buffer thins. And when a neurological insult arrives, there is less cushion to absorb it. So what counts as learning? Not everything engages the brain equally. Passive consumption, watching TV, scrolling social media, reading headlines without depth provides almost no neuroplastic stimulus. Your brain needs novelty, difficulty, and active engagement. The most powerful brain-building activities share three properties. They are new to you. They are difficult enough to require focused effort. And they involve multiple brain systems simultaneously. Learning a musical instrument hits all three. It demands motor coordination, visual processing, auditory processing, timing, memory, and emotional expression all at once. No other single activity engages as many brain regions simultaneously. A 4-year study found that older adults who continued learning an instrument preserved gray matter volume and working memory far better than controls. A massive study of nearly 11,000 people over 70 found that even engaged listening to music significantly reduced dementia risk. Learning a new language is another high-impact activity. It forces your brain to build and maintain two parallel communication systems and constantly switch between them. This strengthens executive function, the ability to focus, switch tasks, and inhibit impulses. Bilingual individuals consistently show later onset of dementia symptoms compared to monolinguals by an average of 4 to 5 years. Learning complex physical skills, things like dance, martial arts, or new sports, combines cognitive and motor demands in ways that stimulate both gray matter growth and white matter integrity. Your brain has to plan a movement, execute it, monitor the outcome, and adjust in real time. This is neuroplasticity at maximum activation. Even structured academic learning in later life produces measurable results. A 2025 clinical trial tested a program called Mental Training Tech, which exposed healthy older adults to brief daily sessions of learning unfamiliar scientific facts combined with memory techniques like braille reading and non-dominant handwriting. The idea was to challenge the brain with genuinely novel material that activated underused pathways. Participants showed significant improvements in global cognitive scores compared to controls. Speed of processing training deserves special mention. The active trial followed nearly 3,000 older adults for 20 years and found that one specific type of training, practicing rapid visual identification under time pressure, reduced the risk of dementia diagnosis by 25% over 2 decades. Each additional session lowered the risk by another 10%. Memory training and reasoning training did not produce the same long-term effect. It was specifically the speed and divided attention component that built durable protection. Here is the practical framework. You do not need to enroll in a university. You need one ongoing learning project that is genuinely new, genuinely difficult, and requires your active participation. A musical instrument, a language, a complex craft, a challenging game like chess or Go, a technical skill like coding or woodworking or drawing. The specific domain matters less than the 3 criteria: novel, difficult, and active. Commit to 30 minutes a day. That is the dose that most studies associate with measurable neuroplastic benefit. It does not need to be consecutive. 3 10-minute sessions work. The key is daily consistency, because neuroplasticity is driven by repetition. Your brain does not remodel from 1 session. It remodels from 100. Combine your learning with physical activity and social connection whenever possible. Exercise increases BDNF and blood flow to the brain, making the learning session more effective. Social learning, like a group class or a conversation partner, adds emotional and linguistic processing that solo practice does not. Avoid the trap of doing things you are already good at and calling it brain exercise. Doing a crossword puzzle every day when you have been doing crosswords for 30 years is not learning. It is maintenance. Your brain adapted to that challenge long ago. The neuroplastic stimulus comes from struggle, from the feeling of not knowing, from the uncomfortable gap between what you can do and what you are trying to do. That gap is where growth lives. Your brain at 70 can grow new neurons. It can form new synapses. It can reroute around damage. It can physically increase in volume in the areas you challenge. But it will only do these things if you give it a reason. The reason is learning. Not because it is good for you in a vague eat your vegetables way. Because it is the literal biological mechanism through which your brain maintains itself. Stop learning and your brain starts quietly, invisibly taking itself apart. Keep learning and it keeps building. The choice is that simple. The biology is that clear. Share this with someone who thinks they are too old to learn something new.